You know, when most of us hear the word engineering, our brains instantly jump to complex math equations, massive blueprints, or somebody coding away on three different monitors. But today, we're going to dive into how engineering is actually way more than just a technical discipline. It's literally the fundamental architecture of our society. It dictates how we live, how we get around, and most importantly, how safely we do all of those things.
There's this really powerful truth in the engineering world. Engineering decisions can save lives or cost them. Responsibility defines the difference. And honestly, that is not an exaggeration. The stakes we are talking about today are incredibly high. Every single steel beam, every electrical circuit, every single line of code carries real human weight. So in this explainer, we'll be mapping out a journey through 4 key areas. First, we'll look at the incredible power engineers have to shape society. Second, we'll confront the grim reality of what happens when engineering fails. Third, we'll break down the strict ethical obligations that bind the profession. And finally, we'll wrap up with how we're designing a sustainable future. Okay, let's jump right into part 1, the power to shape society. It's easy to forget that technology and human behavior are basically stuck in a constant, endless feedback loop, and engineers are standing right smack in the middle of it. A modern professional engineer isn't just a human calculator. They're critical decision makers. Sure, they absolutely have to design safe, efficient, and reliable systems, but they also have to adhere strictly to professional codes, maintain their competence through lifelong learning, and, perhaps most crucially, they have to communicate clearly and act independently. They aren't just accountable to the person signing their paycheck, they are directly accountable to society and to future generations. And you can throw out that old myth of the lone genius toiling away in a dark basement. That's just not how it works anymore. Modern engineering is incredibly collaborative. It requires deep, continuous communication with stakeholders, policymakers, and the general public. You essentially have to translate highly complex technical risks into everyday language that society can actually understand and prepare for. But here's the catch. Because engineers act as this bridge, they're wielding a massive double-edged sword. On the bright side, engineering drives huge increases in productivity, builds better healthcare systems, and literally connects the globe. But on the flip side, we're dealing with job displacement, serious privacy concerns, the digital divide, and some pretty severe environmental damage. Balancing that requires incredibly careful, ethical management to make sure the scales tip in humanity's favor. Which brings us to a much heavier topic, Section 2, when engineering fails. So what happens when that delicate balance isn't maintained, when speed, cost-cutting, or just flat-out negligence overrides ethical management? The consequences are visceral. Just consider the chilling pattern of industrial disasters we saw in Bangladesh over the years. The 2005 Spectrum factory collapse, the 2012 Bahadur flyover collapse, and the catastrophic Tazreen factory fire. We aren't just talking about a string of bad luck or random accidents here. We're talking about a chilling pattern of systemic failure. The sheer, utter destruction of the 2005 Spectrum factory collapse in Savar wasn't some unavoidable act of nature. It was a complete failure in structural design, a failure in regulation, a failure in enforcement. When the fundamental bedrock rules of engineering and construction are compromised, the direct cost is paid in human lives. It's a very similar story with the harrowing 2012 Tazreen factory fire in Dhaka. The massive number of fatalities in that tragedy highlighted a severe, critical lack of emergency egress in industrial buildings. It's a stark reminder that an ethical duty to ensure safe design and strict code compliance is absolutely vital. You aren't just drawing up a building, you are literally designing the escape routes that let people survive if the worst-case scenario actually happens. The takeaway here is simple. And honestly, it's absolute. Safety is a non-negotiable obligation. It is never a trade-off for cost, and it's never a trade-off for time. Commercial pressure from an employer or an aggressive client deadline can never, under any circumstances, be used as an excuse for risking the public's lives. Period. Let's shift gears to how the industry handles this. Section 3, the ethical obligation. Because the engineering profession knows exactly how incredibly high these stakes are, they've built up a very robust web of accountability. An engineering failure is never just an oops, my bad. If an engineer is negligent, lets design flaws slip through, violates safety regulations, or engages in professional misconduct, they don't just lose their job. They face severe, life-altering liabilities. We're talking civil liability where they can be sued for everything, professional liability where they lose their license to ever practice again, and yes, criminal liability where they can actually face prison time. But beyond the strict letter of the law, there is the daily, lived ethical code. Engineers absolutely must work with integrity, avoid conflicts of interest, and respect client confidentiality. But maybe the most crucial point of all, an engineer has the absolute right and the professional duty to outright refuse unsafe or unethical instructions. If a manager tells an engineer to cut a corner that compromises safety, the engineer's duty to the public overrides their duty to their boss. Every single time.
All right, let's bring the energy back up and look forward. Section 4, Designing a Sustainable Future.
Having looked at the really heavy reality of these responsibilities, we've got to look at how responsible engineering is proactively solving tomorrow's massive problems. You've probably heard of the Global Sustainable Development Goals. Well, for an engineer, sustainable development means creating solutions that meet our present needs today without stealing resources from future generations tomorrow. It rests on 3 vital pillars: environmental sustainability, economic viability, and social responsibility. To really ground that abstract idea into reality, let's take a specific local example right in Dhaka, the new Farmgate Foot Overbridge. This project isn't just a slab of concrete and steel. It was specifically engineered to vastly improve pedestrian safety in a notoriously chaotic, high-traffic area. It features a design that's directly inspired by local culture, and it integrates user safety through continuous surveillance like CCTV. It's just a brilliant, tangible example of a solution engineered specifically for the betterment of everyday society. And man, the future holds even more incredible potential. Right now, engineers are rolling out massive solar and wind power projects. They're designing entirely new, hyper-efficient transportation systems, inventing low-carbon manufacturing processes, and building smart infrastructure that literally adapts to our needs in real time. They have the tools right now to build a far more resilient, equitable world for all of us.
Ultimately, this entire explainer really boils down to one single truth. An engineer's true responsibility begins where technical work meets human welfare. The complex math, the cutting-edge science, those are just the prerequisites. The actual job is ensuring human flourishing. So I want to leave you with a thought. The next time you walk across a towering bridge or step into an elevator or just walk into a massive office building, ask yourself, who are you trusting with your life in that exact moment? The answer is an engineer, someone who took a profound ethical oath to protect you. Thanks for joining me for this explainer, and I really hope you walk away today with a profound new respect for the invisible safety nets that are designed all around us.